Okay, well, I said again, welcome to 6950 for today, May the 13th. The game plan today is to do a little bit more on the shell, and specifically, I want to talk about something called secure shell and how that starts to let you use multiple computers at one time, a little bit of bash customization, and then try and move on to uh, Git all the way through. There was a question in Slack for each week. We have 2 assignments. For every class, I'll try and have an assignment. You got to remember when we meet for an afternoon, that's equivalent of an entire week of normal class time. This is only a 6-week course, so every meeting is equivalent to one whole week of normal time. So, anyways, yeah, roughly speaking, an assignment a day. Um, sorry, I'm just taking a look here in Slack. Arnab put an error he's getting. He's getting wget resolving. Okay, so you're saving it to that file. Okay. I'm not sure you're actually getting a binary file. So when I said, did you look at the file? Did you actually open it up? Like try, oh, I should do this. I'll demo this, and this will be a good way of leading into everything else. Here, let me share a screen. No, which button? Which button? Share screen, share. Okay. Let's just tackle this for a moment. Okay, so there I've got a terminal. So what we're going to do is we're just going to start by diagnosing a problem with doing the assignment number 2, which is getting some data. And I said what you could do is you could have a terminal, and the key thing here is we got to be in a Unix-like environment. I don't care if it's Linux, Mac OS 10, WSL, a remote server. The idea is you want to be somewhere where you can do stuff. And I said try and get the file completely from the command line. Oh well, that's no good. Clear. So if we were trying to get that file, okay. So a couple things here. So this thing downloaded this file. It's a zip file. So the first thing to do is be like, well, what did I get the right file? Okay. So this file downloaded. It's 111 kilobytes. That's a good sign that worked correctly. If you want to find out what kind of file it is, there's a command called file that says it will take a look at what's inside. And you can see that what's inside is not a zip file. What's inside is actually an HTML document. So let's take a look at that HTML document and find out what's going right or going wrong. And here's the problem. The content is not a zip file. Okay, now you'll look at that. That's a web page. So what the issue is there is the link that I've given you is not the raw file all the way through. So this is a little bit of debugging. When we want a file like that, I actually want to go to the raw file that's underneath the whole plan. Okay, well, that's weird. I'm just trying to find the actual assignments, contents. Copy link. Yeah, that's a lot better. Okay, so just in terms of digging around, and I'll sort of explain what's going on here. And these are exactly the skills that I'm trying to get us to practice and try and be able to resolve. How do you resolve issues like this? So let me just share. Let me share everything for a moment. I know it's a bit smaller and harder to read, but here's the issue. I said go off and find this file, and there was a link, and I gave you a link, and the link was this thing right here. And as you identified, if I go to this link, Rabernat Research Computing Blob Master Context File, notice how I'm not getting a file. okay, I'm getting a link to a web page, right? To actually download the file, it's this link right here, okay? And if I click that link download, it dutifully downloads the file, okay? So this is the file that we actually want to download. If I was to right click on that and then hit copy link, that will be the link to the actual file we're interested in here. So I'll put this into the Slack chat for those who haven't been able to figure it out. Right, so there is a command to download the actual file, and the difference here is the letters RAW, raw. That is the command that would allow you to download that file. It's slightly different than the URL, and what I meant by look at what you had downloaded was actually open it up in a text editor. Take a look at the file, and you would see that it's not a corrupted file. It's just downloaded the web page of this thing, not the underlying content. Well, once we've done that, we can unzip that file, and we see that we get signif.txt.tsv. It's a tab-separated file, and you should be good to go. Is that enough of a hint, Arnab, to be able to keep on going with that assignment?
Yes, Professor, it solved my problem.
Okay,
Actually, try it now.
Yeah, but
Thank
those
you.
are very much the steps to try and work through to be able to figure out what's going correctly or what we need to fix. Okay, so as I said, let's continue on here. I'll make this a bit bigger so you can see it. Okay, so the first thing I want to talk about today is I want to talk a little bit more about working remotely with a computer. So the reality today is you're never working on one computer. You're working on a laptop, you're working on a desktop, you're working on some server in the cloud, you're working on a high performance computing system in another part of the country, you're working on a computer in your research group. We're working with lots of computers at the same time. Even on your actual computer by itself, when you're sitting here on a computer, like you're facing a screen and a keyboard, you may actually be interacting with more than one operating system simultaneously. So what I'm looking at here, when I say uname.a, this is a Linux machine with the name desktop, but it's actually running on the same machine as a Windows 10 operating system. There's two different machines there. So one of the skills is to be able to connect to and work remotely from these kind of machines. Now, we've seen this before in the sense that I've set up a machine for you that is called, that has the name, and we can, here, we'll do an NS lookup. NS lookup of CMSC6950.monroelab.ca. Now, if you've ever done anything with networking, or if you haven't, right, this is sort of one way of referring to a computer. That's the name that we give it. It's called the host name or the fully qualified domain name. But of course, the computer itself knows this by its internet protocol address, its IP address. And so this is the number which how networking works, it's sort of mapped to that number. So when I try and connect to that machine, I've got to use a piece of software to connect to it. And one of the things we had talked about was using SSH to connect to this machine. Okay, now by default, when you do something like this, it will log in with whatever username you are currently set up with. So if you set up your computer so that your username for the machine you're logging in from was the same as the machine you're logging into, this is all you need. However, often what happens is you have a different login on the remote machine as you do on the current machine. So there's a number of switches we use with SSH to be able to specify how it works. Okay, and the common way of doing that is we put our username at the front. Okay, the act of doing this runs a program called SSH, Secure Shell, which connects to that remote machine, and it's asking me for a password. That's the password on the remote machine, so I can log in. And again, for this machine, I've created accounts for all of you if you just want to play around with it. The password is CMSC6950. Okay, so if I log in, you'll see a couple things. One is the prompt has changed from jmonroe at desktop to J Monroe at CMSC6950. So I'm now on another machine. I'm connecting remotely through this thing called secure shell. So we know that the prompt has changed. That tells us what machine I'm on. If I do a listing, I've got different files than I might have on my current computer. W is a way of saying who else is logged into the machine. And so I can tell right away that at least these people are playing along at home, which is fantastic. Okay, so I can interact with this machine through the shell. This is why I wanted to start with the Unix shell, because this is sort of a fundamental way of connecting with a remote machine. There are other tools, more graphical ways of doing it, but this is like the core plumbing of how we connect to remote machines. Okay, so one of the things that we often need to do is we've got some file on this remote machine and we want to get it connected back to the local machine. Okay, so let's be specific about this. On this remote machine, there is this file called solar.pdf. Okay, so solar.pdf is a file that is on this remote machine. I can figure out what kind of file it is by typing in solar PDF, and it says this is a PDF document. Now, my only connection to this machine is this text interactive. There's no way to say open solar.pdf. It goes, I don't know what you mean. PDF reader solar.pdf. It doesn't make sense. What do we do? Well, one way of solving this problem is to get this file from this computer back to the original computer. So I'm going to play a little bit of a game here. As I said, I'm using Windows Terminal, and one of the things you can do with Windows Terminal is I can open additional tabs, so I can flip back and forth between two different machines. The other thing that I can do, and you see in the tab, if I hold down the Alt key and then click, I can split my screen. Okay, so now I'm looking at two different screens. Anything on the left-hand side is the remote machine. Anything on the right-hand side is my local machine. Okay, and what I want to do is I want to get the file from the local remote machine and move it all over. SSH is how you connect to it. SCP is secure copy. And what that does is it copies a file from a remote machine to a local machine or vice versa. Now, you need to talk about what machine you're connecting to, what user you're connecting at, and then the path. And so these ideas all get together. So if I want to copy this file, specifically, whoa, that's going to be hard to read, solar.pdf. What I want to do is I want to copy from the J Monroe account at CMSC6950, monroelab.ca, and then you put a colon and you specify the path of this file. Now, if you put a / in, that'll be an absolute path, but if you leave it out, it'll be relative to your home directory. So relative to your home directory, data shell / solar.pdf. This is the full descriptor of the file that's on the remote system, and I want to copy that to my local directory. And one of the things we learned about on Monday was the pattern or the name for a local file or a local directory or the current directory is just dot. So the effect of this command is to copy this file remotely, locally. Now it's going to ask you for a password, right? Because we want to be secure about these things. Okay, it's saying I copied 21 kilobytes all the way through. If I do a listing, I now see this file. Now this file is something. Oh, open doesn't work. Because I'm using Windows Subsystem for Linux, I can drop in and use some other tool chain. Let me just share, new share, entire screen. Okay, so this is what I'm looking at right here. I'm just going to open up and run explore.exe. That gives me my entire environment, right? And then I can just go to solar.thing and open it up with a tool that has graphics like Adobe Acrobat, and we can see what's inside the file, right? And there we go. There it is. This is obviously someone's thesis, and all they have to do is write the thesis. So, you know, they've started, they got a title, The effect of solar wind on lycanthrope mutability. Fair enough. But that's this idea of copying files back and forth. There was a question in the chat. Can you show this in Mac OS? It's exactly the same. Like literally, there is no difference between Windows and Mac OS here. On your Mac OS system, you have a prompt. You have to open the terminal. Use SCP, and I said I'll just put this line in the Slack channel, so you, in case you want it for yourself. Oh. Okay, there's the example. Obviously, change the username. So if you type that in from your Mac OS 10 shell, my expectation is you should be able to copy this file over. And then if you were to do something like open solar.pdf on Mac OS 10, you'd see the file. So it's this idea of copying files from one system to another. You can do this back and forth. I can copy files from the current machine to this remote machine. That's allowed. You can copy multiple files at once. You can copy a directory recursively, right? So if you continue to sort of take a look at it, I may have some data on this local machine that I can push up to the remote machine. Okay. Jingyao has just pointed out a very common warning that pops up, and it's talking about a fingerprint. Okay, so here's the thing about what makes Secure Shell secure. There's a fundamental problem in how you connect two computers together. Okay, so again, this is my remote machine. This is my local machine. And I want to log in from this machine to this machine. Okay. Back in the day, okay, not that many years ago. Okay, I guess it is that many years ago now. But let's say 20, 25 years ago, Secure Shell was out there, but no, people didn't use it. What they used is something called RSH, Remote Shell. And what Remote Shell did, or Telnet, or any of these kind of tools, is they would try and connect to a remote computer. But the problem was the actual password you typed in was being sent over the internet as characters. And anybody on the internet could just take a look at those characters as they went by, and then basically take your credentials and see what you were doing. So we needed a way of talking to a remote computer through a cryptographic technique, some way of encrypting what we were saying, including your password, so that you could connect to that remote machine. But there's one problem with this scheme, is if I try and connect to a remote machine, okay, and I do something like this, SSH J Monroe Lab, there's no guarantee that the computer I'm connecting to is actually CMSC6950.monroelab.ca. It's very possible for an attacker to come and create a new machine with just this name. Remember, this name maps to a number. So if I was to compromise whether or not that number matched to a specific number, what I could do is I could make this prompt and then basically steal your password when I typed it in. And so what a fingerprint is it's a unique way of SSH going, is this the particular machine that you want to connect to? And so the very first time you connect to a machine, it gives you a fingerprint. And that's what the ECDSA key fingerprint is. Usually what you do is you say yes, and then every other time you connect to it, it will check to make sure the computer has the same fingerprint. Now, strictly speaking, if you were doing something super secure, you'd want to know what that fingerprint is from a third-party source. You want someone to tell you what the fingerprint is that you are connecting to. The short answer is you just type in the letter Y, return, or yes, and you keep on going. But what's going on is some cryptography to ensure that you're not going to be exposed to what's called a man-in-the-middle attack, where some computer is pretending to be the computer you're connecting to. Incidentally, what that means is if at any time your remote server keeps its name but changes its underlying operating system, it gets reset, it gets reinstalled, it is possible for that fingerprint to change. And so you'll get a warning or an error saying, the remote key has been changed, and you got to fix that. But that's all that's going on back and forth. Okay, so there's more that you can do with SSH. I'm just gonna close this one up. Besides logging in, you actually can do a remote command on a machine. So let's just say that I was interested while on my current computer to figure out what's on a remote computer. By default, what happens is it just goes and runs it. But what I can do is I can actually run a command remotely on that computer. So I talked about W being the command that says who is currently on there. So even though I'm on my local computer, I can run this command W and find out. I can log into that computer and I can find out who is currently running on that machine. But notice I'm back on my local desktop. I haven't jumped to that remote machine back and forth. And so you could imagine you may have a number of things you like to ask about a computer. Uptime. How long has that computer been turned on, right? So we send off the command, we type in the password, and we find out that this machine has been turned on for 3 days, and there's currently no one's really using it for anything. There's a whole bunch of things you may want to do remotely. Now, here's the reality. Very, very quickly, this starts to be a drag. You're using multiple computers. Why am I being asked for my password every single time? Isn't there some way of making it so that you can say, computer, no, it's really me, I'm James, just use my password? And there is. And what we're going to do is talk about how that's done, and it's done with something called SSH keys. Okay, so what we're going to be talking about here is SSH keys. Okay, that's the idea. They're keys in the sense of cryptographic public-private keys. So if you know anything about encryption or cryptography, you'll understand this. If not, it's a mathematical algorithm basically ensures that the person I'm connecting to or sending a message to, they can verify that the message came from me. And we do this in an asymmetric way where I can prove that the message came from me without sending you my private key. And I can do that by sending you a public key. And a key is just a number. It's a long digit number that mathematically is used to connect to that remote machine. Okay, so these keys may already exist, and where they exist is inside a hidden directory. And so I'll do it like this, dot slash SSH. So on your home directory, inside SSH, I'll just go back and share screen. No, share screen, do share. I know it's easier to read if I make it big like that. Okay, if we go into that directory and take a look at what's in there, there's a few files. One of the files might be IDRSA and IDRSA pub. That is a private and public key. Now, if you don't have this directory, okay, and you're like, that didn't work. It said it didn't work for me. Here's what I want you to do on your Mac OS 10, Linux, WSL, whatever system you have set up. SSH key gen. Okay, so what SSH keygen does is it generates a unique public-private key pair for you, okay, for your machine. The convention is this file gets stored in IDRSA. Okay, well that's fine. I'll just overwrite mine, make it brand new. That's not a big deal at all. If you don't have one, just say yes and it'll create it. Then there's this idea of a passphrase. Now, security. What is the point of removing a password if all you have to do is then have a passphrase on your private key? Proper security says you're supposed to put a passphrase in here. In the sense, it's another password, but when you actually use it in practice, you use something called an SSH key agent that unlocks that private key so that you only have to type in that passphrase once per day, once per use. If you are security conscious, it is best practice to use a passphrase. But my own self, I have gone through years where I'm like, yes, I have to use passphrases and everything, and then I get lazy. So for the purposes of right this moment, no passphrase is totally fine. However, best practice is to use a passphrase and SSH agents. But we'll just go with this level of depth for right now. There's lots of applications where we don't use a passphrase, especially automated things. Okay, so what we've done is we've created a pair of files called IDRSA and IDRSA.pub. Okay, ID is identification. It's basically your identifier. It's what we're moving. RSA is the name of the algorithm, the mathematical algorithm. And what the name is that? Rivas Shamir Alderman, right? So it's basically, I remember learning this in university. It's basically modulos. It's basically a bunch of modulos of two very big numbers. You take a message, you modulate another number, and because prime factorization of really big numbers is hard, that's the basis of the algorithm. Anyways, what we've done is we've stored in these two files two numbers. So now that we've done that, let's go into the SSH directory and take a look at what's here. Okay, you've got two things, at least two things. You're going to have a file called IDRSA, okay, and it'll be about 2 kilobytes. It should have permissions that it is not readable by anybody else. This is what's called your private key. It's private in the sense you never share it with anyone. You don't give it to another computer. You don't tell anybody about it. It is the mathematical number that is your secret. Now, I'll change this after this class, so I don't need to worry about it. I just created it. I will show you my private key. I said, don't worry, it doesn't actually connect to anything at all, so I'm not worried about it. Here is my private key. Now, it looks like a bunch of text, but I'll remind you that the way that numbers on computers are stored is they're stored basically with a table that assigns a character to a number. And so with the ASCII table, every one of these letters represents a number between 0 and 128, roughly speaking. I think this is base 64 encoded. But the point is, this can be mapped to a number which has thousands of digits. Okay, I think it's about, I don't know what that would be, a 4,000 digit number if you expect it out, something like that. It's literally several hundreds of numbers. This number is the private key. The private key you can think about as being the product of two very large primes. That's one way of understanding what a private key, or rather, it's one of the primes in a product. What I can do is from a private key, I can actually generate this other file, which is called the public key. Now, the public key is supposed to be public. You have to give this to somebody so that you can send them messages to know the message they're sending is actually coming from you. This file, you can very safely send around, and it's much shorter. I think it's a base 64 encoded file with a little note saying it came from J. Monroe desktop. This is the file that if we put onto the remote machine, then we are able to log into it remotely. So here's what we're going to do, okay? So you're going to have two different things going on, right? So you're going to have your local machine, and you're going to SSH into your remote machine. 6950.monroelab.ca. Okay, I haven't set up anything, so there's a password. Okay, just so that I am the same as you are, I'm going to get rid of my SSH directory, so I don't have one. Okay, so there is no SSH directory. What I'm going to do is I am going to create an SSH directory on my remote machine. Okay, and I don't care if you use terminal or you just open two terminals for yourself, but I want to make sure that you've got a SSH directory on the remote machine. And now what we need to do is we need to take this file and copy it from here to here. Now, there are programs like SSH copy key that do this operation for you, but I want to break it up into pieces. So what we're going to do is we're going to copy this file idrsa.pub, and I'm going to copy it to this remote machine. Okay, so I'm going to copy from here to there. How do I do this? I copy the local file to jmonroe at SCMCN650 monroelab.ca, colon, and then we put in the relative path, dot SSH slash dot. Okay, so what that is doing is copying a file from my local system to this remote system into that directory. Okay, it's going to ask me for the password. We're very close to not ever having to do passwords again, but we type in the password. Okay, it copies it, 577 bytes. And then on the other side, we see this file. Now, here's the trick. On the remotes file, it's not supposed to have this name. It's supposed to be called authorized keys. So what we do is we rename this file so that instead of being called idrsa pub, it is called authorized keys. Okay, the permission should be readable. And what this means is now, if I do an SSH to a remote machine, not monroelab.ca. Okay. Notice how I ran a command and there was no password. I can now SSH to that machine. No password. I can copy files to that machine. No password required. Okay, so setting up these SSH keys is a great way when you're working with a remote machine of just making your life easier. Okay, now it doesn't go the other way. Okay, so if I'm on the remote machine, I can't log into this machine unless, say, I create a SSH key on this side to connect to this machine. So often what happens is people create an SSH key on one side, and on the other side, if they've got two computers they want to talk back and forth to. Okay, so that's the first big idea, is this idea of creating SSH keys. And again, I'll just in Slack here just do a few little notes so you get the history of what we were talking about. Okay, so here are the important commands that we talked about. SSH keygen. We talked about copying. Okay, and you know what? I'm going to make life a little bit easier. No, we'll do this. Like that. We talked about renaming. Okay. Sorry, I'm just making some notes for you. Yeah, there we go. So what I've done is I've made it clear which ones are in Slack. You'll see I have just little notes. SSH keygen, copy the file over, rename it if you need to. There's ways of making that even tighter and more quick, but it's the basic the basic idea all the way through. Okay, so what that means now is when I try and connect to a machine, if there is an identity file, it will use that and make it so that I don't need to type in a password. Okay, there's more. There's more things we can do to make our life a little bit simpler. Again, I'm going to get rid of this shell right here so you only see one screen. If I go into that SSH directory, okay, you'll see some files here. First of all, we talked about ID RSA and RD pub. Known hosts is a list of all the private keys of computers we have connected to. So if you look at known host, you'll see a bunch of lines in it. And one of these is going to correspond to the private key of the computer I just connected to, that remote machine. I connect to lots of machines. What I want to focus on here is this file, a file that has the name of config. Okay, so what I'm going to do is, because I already got a config, I'm just going to make it a backup so that it doesn't confuse the system. Back config. There we go. Go away. No, move config.back to back_config. Oh, it's executable. Well, that's not good. I don't want it to be executable. Change mod -x back config. Okay, let's start again. Open up an editor. And remember how I talked about before the importance of having a way of editing files on a remote machine inside the terminal? This is an example of where we want that technology. You might like to use a graphical editor, but sometimes you just want to be able to open up a file and edit it right in place. So if you like to use Nano, use Nano. If you like to use Emacs, use Emacs. I like VI, so I'm going to edit a file called config. Okay, so here's what config has inside of it. What I'm going to do is I'm going to add some lines to it, and I'm going to create something called a host, and I'm going to call that host 6950. Okay, so that's the first line, is the word host and 6950. And then I'm going to type in what's called a host name. So this is the fully qualified name of the computer I want to talk to. And then there's a key called user, where I can type in the username that I want to use. So those three files, and again, I'll just throw this on Slack so that those who need it can have it. Right. So there's this file. So this is the 3 lines you would need. If you put that inside your .ssh.config file, what that does for you is now if I do an SSH to CMSC6950, without having to type in Monroe Lab or without having to type in my username, I jump immediately to this remote machine. And this kind of functionality is what makes this start to be quite powerful. I now can copy a file from the local system to my remote machine. I can copy a file from a remote machine to my local machine. Okay. And the reason this all works now without having to type so much in is I have configured SSH so that it knows when I talk about CMSC6950, what that means is this is the host name I want you to use. This is the user that I want you to use. Now there is one other distinction. You actually can have multiple identity files. An identity file, identity file. Okay. This is the private key you're using to connect to that remote machine. By default, it's ID RSA, but you very well may have lots of private keys. And so you want to be able to figure this out. So just as an example, this is another one of my computers that I use. I have lots of different systems. Here is my SSH directory on a machine that I actively work on. You'll see that I have private keys for a number of different systems all the way through. And here is what my config looks like for all these different machines. I have a config for this course. I've got a different identity file for a server in Australia, a different server for one in Dalhousie, a different one for one in AceNet, a different one for a machine on Compute Canada. And so these machines all have different hosts, host names and identity files and users because I'm known by different usernames on different computers. I use JMonroe when I have the option, but in Australia, I'm known as JM0634. And sometimes I need to pretend I'm somebody else. So here I'm known as JTomp for different machines all the way through. So configs are really nice, SSH configs, when you're dealing with lots of other computers back and forth. Okay, so the lesson here is when you're dealing with remote machines, definitely spend a little bit of time learning something about SSH, SCP, because they can be helpful tools. Now, I'm just going to go back and fix this because I blew it away. SSH config, great. SSH CM SC6950. This is one of those moments I get worried. Could someone give me that, like, because no one turns on their camera, I can't tell whether or not I'm connected or not.
I can still hear and see
Awesome.
James, if that
Okay,
helps.
so this is just this. Yeah, it does help. So this has just died. Okay, it does help. Thank you. Well, I don't know what happened there. Well, then we'll do what's normal in computers. Turn it off and turn it back on again. That was weird. 6950. Didn't we just do this? Oh, I changed the key. The problem with doing demos on your actual work is it tends to break things. Okay, so I just want to talk about SSH keys. Okay, here is another scenario where you may care about SSH and connecting the machine. So I've been demoing using a terminal on my local machine, and that terminal is actually a Windows subsystem for Linux. It's a virtual machine on my home machine. Sometimes, often, you're doing a project, and this could be for computational research, it could be for development. A lot of you in computer science, developing things on the web is common nowadays. How do you go about setting up a remote machine that you go and connect to? So I just wanted to do a little side trip here on a place where you may be wanting to use SSH keys and wanting this stuff all set up. So I'm going to go and share the entire screen so that you can see what's going on here. Make that a bit smaller on the right-hand side. Okay, so do you remember how I asked you to go to GitHub, set up an account, and one of the things that you could do is you could sign up for what's called the GitHub Student Developer Pack. And there's a bunch of, like, free for 1 year, subscription, free. A lot of things you get when you're a student. There are many of them. I'll point out Azure is an example, AWS, Google Compute Cloud, or this thing called DigitalOcean are all systems that let you create your own computers in the cloud. And when you sign up for DigitalOcean, either using the Student Developer Pack or just by yourself, you're going to get $100 in credit if you're a new user. So let me just show you what that's like and how SSH plays into it. So DigitalOcean, which is like Amazon Web Services or Google Compute Platform or Azure, are basically farms of computers that you can create on your own. I like DigitalOcean because it's quick and it's easy and it's simple. You see that the basic page, digitalocean.com. I am not paid by these guys. This is not my a company that reimburses me. I just tend to use it. You can create an account and deploy it in seconds. You can sign up. What I'm going to do is I'm just going to sign in with an account that I've already got. Okay, so I'm connected to this thing. It's affiliated with mun.ca is the account that I'm working on, and I don't currently have anything set up on this account. If we go down and we go to manage and we go to droplets, Droplet is the name that Ocean Cloud uses for one of its virtual machines. So what this is you're creating a whole computer somewhere in the cloud to test something, to get more processing power, whatever you want, right? Because often for testing purposes or development, you just need another Linux machine somewhere in there. So if you go to one of these sites and if you logged in as a new user, you got $100 of credit for this kind of stuff, and you click create Droplet, what you can do is you create an operating system. Now, There's a whole bunch of operating systems set up, Ubuntu, FreeBSD, Fedora, Debian, whatever. Let's just set up a Ubuntu machine. And then you get to choose what kind of computer it is. Now, you could just choose basic, okay? And what basic means is it's one of these computers, okay? Now, I want to see what you're actually looking at here. For $6 a month, you can run a small computer with a single CPU and 25 gigs of space, and it just sits there running. Or for $96 a month, you can spit up a moderately beefy machine with 16 gigabytes and 8 CPUs. Now, you might have that kind of workstation, but maybe you want to have twice as much power. You can sort of spin it up. Let me continue to show you what's out there. You can say, you know what I really need is I need a powerful machine to do some calculation. You can spit up a machine like this that's got 32 CPUs, 64 gigs of RAM. So it's a pretty decent machine. Now, if you ran it 24/7, that machine's going to cost you $640 a month. But the point here is it only costs you 90 cents an hour. So if you had a piece of work that would run efficiently in an hour or two, if you just had this kind of machine, these services can be really useful. Memory optimized, right? I don't have 256 gigabytes of RAM in my home computer, but maybe you're doing something that just for the purposes of that calculation, you really would like that much RAM. It's going to cost you $2 an hour. Remember, you have $100 free credit, so 50 hours of processing. Now, definitely do not leave this thing running. Shut it off, but it can be useful. But for the purposes of right now, what I'll do is I'll just spin up a basic one, something sort of middle of the road, a 4 CPU machine. If I was to leave it running, it's going to cost $48 for a whole month. It's going to cost me 7 cents an hour. I'm going to splurge and spend 7 cents an hour for this demonstration. You're able to choose where in the world you want that computer to be. Amazon Web Services, Google Compute Platform, and Azure are the big players in this space, and they've got a lot more machines. DigitalOcean is just sort of a smaller player, but it's sort of useful and quick and easy. I could create my computer in Toronto if I felt that I needed to have that data local. I could also create it in Amsterdam, San Francisco, Singapore. You know what? I'm just going to create it in New York. Beyond that, I can take the defaults for everything until it gets to this point, which talks about authentication. Now, for authentication, I could create a password, as in type in your password, but those are less secure. In practice, what we do is we use an SSH key, okay? Well, where do I get my SSH key from? Well, your SSH key, if I say new SSH key, what it wants is it wants the string that we uploaded to that remote machine. It's actually giving you instructions. It's saying, how do you do this? Use SSH keygen. And then you will get a phrase, and they want this public key. So if I do that, okay, so I go into my machine, and I say, okay, well, what is my /SSH ID.ispub? This is my public key. I take this, I copy it, I paste it, right? Name cannot be blank. Okay, I'm just going to use this as my name. What I'm doing is I am doing the equivalent of sending the file to that remote machine so it knows about it. So it's saying, yeah, okay, your SSH key is this one right here. You can give it a name. This one's given the name of the operating system, the size of the computer, and then where it happens to live. And I can hit create. And what it's doing now is it's creating a computer on this remote machine that happens to live in New York, which I can work on. And if I go down to droplets, you'll see that it is installing a computer. So this is effectively the same as getting a computer, cleaning it all off, putting an operating system on it. We're done. Okay. That computer is now running. There is a brand new computer out there. Just think about how long it would take you to install an operating system locally. It would take you a few minutes to find the disk, clean it off. We're done. We've now got a nice, clean, brand new 8 gig 4 CPU machine with an IP address that I'm able to use. So I copy that IP address, go back to here, And now I can SSH to that directory. Now, if I SSH to that directory, the very first thing it's going to tell me is, you've actually never connected to that computer before. How do I know you can trust this machine? Now, this is where security becomes an issue. If you're doing something on the internet, there are bad operators on the internet. You may want to verify that this computer is actually who it says it is. Okay. That information is somewhere I'm just trying to remember where it appears. Private MPs. I won't do it for you. There is some button on here that I can look up what the private key is, but we'll skip that and we'll just say yes. Okay. And its very first thing is saying permission denied public key, because I'm trying to log into this machine as Jay Monroe. This machine doesn't know anything about Jay Monroe. If you look at the documentation, you'll find out that the default user on this machine is Ubuntu. Root. The default user is root. I just needed to remember how this machine was set up. So root is a user that exists on all computers. I'm connecting to this remote machine. Why didn't it ask me for a password? Because I'm using my default SSH key. Right? You see this one right here? This file's already been copied over to that remote machine. Right? If I take a look at the SSH directory on this remote machine, there is a file called authorized keys, and inside authorized keys is my secret key. And so this is how you can go and you can connect to these remote machines. This remote machine is personal. It's mine. I can create accounts on it, add user. One, two, one. Right. So now there is a brand new user on this machine. I can update files. I can install things. I can do whatever I normally would do. Right here, I'll use update. I can install stuff, and this machine is isolated and clean, and I can do anything I want with it. When I'm all done, I can jump back to whatever my thing is. I'm using here. Go back to my list of droplets, and I can go to more, and I can go to destroy. And what that does is it takes that virtual machine and gets rid of it. Okay, so that demo, it cost 7 cents an hour. It took about 4 or 5 minutes. It probably cost me a penny, but it's a useful tool to have in your toolbox if you just want a clean machine to be able to demo something independent from your computer. You're remotely somewhere. All you've got access to is a simple machine. Being able to spin up a machine in the cloud to do some testing, really useful skill. And using SSH is part of the things that you need to be able to do that. Anyway, so that's sort of a little side thing that might be that. There was a question about Compute Canada. Compute Canada is exactly like this. It's another system that if you have an account on Compute Canada, you can create your own machines in the cloud, which is basically someone else paying for them. Alternatively, you can have access to machines that are quite powerful. Sorry, this is just work I was doing before. Compute Canada. So these machines, which you access with so Compute Canada is something that we fund at a national level to get access on it. There's a few ways of doing it, but usually it's through a faculty member who can put you onto it. Here is the kind of machines that they have on this system. National systems. Yeah, so just to give you a sense of what these machines are. So Beluga is physically located in McGill. It's 700 computers, 28,000 CPUs, all put together. Artibus is a cloud server. Okay, it's 7,000 CPUs across 290 different machines. and there's 1.6 petabytes of storage available. Cedar is sort of Cedar and Graham are two of the biggest compute ones. You could run a job if you wanted to do a 1,280 CPU machine. Other ones of these machines have GPUs on them. You can do big jobs, right? If you wanted to run a program that needed to use 1,000 cores, that's what these machines are for. I said, if you do need this, talk to sort of any faculty member, your supervisor. They probably have accounts on these things. They can give you access to them. If you need to use a lot of power, you actually have to apply for so many cycles on these machines. Do it. Would you help me run a Python code on it? Sure, I'd be happy to omit, but how about you try, in the sense of all you would be doing is SSHing to the machine, some remote machine, uploading your data, uploading your files, and then running Python, right? All within a terminal. So how about you give it a shot, and I'm happy to talk about that with you over Slack or at some other later time. But yeah, incidentally, if you are a Compute Canada user, and if you're not, don't worry about them. I will point out that there are a whole bunch of supports for this technology, right? So you see it says technical support, national experts. Okay, so we are at Memorial University. There are people who are employed to help you with this stuff. So technical support, user documentation, quick links, national experts. Right. So I think there is an email that's support@Compute Canada. But if you had any questions about getting onto it, no, those are the national experts. I want AceNet is what I want. AceNet is a partner within it. What we do with help, quick links, linear skills. Definitely use contact. There, support at AceNet. If you had confused about how do I run Python code on it, I'm willing to help you, but these are guys whose job it is to actually make sure you're using the system. So I would also send an email off to them, because they exist to run this kind of stuff. Anyways, okay, so that's SSH, remote systems. This is why we're talking about this. This is why we care about SSH. It's so we can access this stuff. There's one other thing that I'll just do, because I think it's sort of fun. You'll notice that when I've been logging onto these different machines, right, it's showing me some information in this part before the $sign. This is called the prompt, okay? So it's telling me that I'm user J Monroe, logged on to desktop this machine as this name. If I go off to CMSC6950, okay, you'll see that my prompt has changed, and it's telling me what machine I'm on. If I was to go to a machine, I'm going to just going to pick the first one on the list. If I was to log into that remote computer as somebody else, and I'm just using your account because I know what your password is, 6950, and I can log in, it's now telling me that I'm logged in as this user on this remote machine with this path. Well, that information is something that you can configure. And so I want to talk a little bit here about bash customization. So I will do this on this machine under my own account. There are a number of directories that typically are on a system that may or may not exist for you. And the specific one I want to talk about is bash RC. RC files are configuration files. They're resource configuration files. And anything we put inside of a bash RC gets run when we open a shell. Now, if you're a Unix person, you know that there's some complexity about what kinds of shells run which kinds of scripts. But for the purposes of today, we're just going to go with bash RC is a shell script, and anything inside of there gets run when I log in with a machine. So if I open up in an editor, again, use nano or VI, you will see a bunch of files, okay? And these are all bash commands that are run every time you log in. Now, case we haven't talked about. These are variables. These are other bash commands that you're more than welcome to look up, and they configure a whole bunch of things that are normal. Okay, so number one, it's setting some things about the history, like how long your history should be. If you want your history to be a larger size, you might want to change it in here. If you want to change the prompt, okay, this stuff is setting up the prompt. And it's giving you this line that says, if I figured out that you're on a terminal that has a color prompt, use this as my prompt. Okay, well, that's a little bit weird. What if I wanted to change this? What if I wanted to make it look somewhat different? How do I even go about reading this? Let me explain. The prompt is, so set is a routine that gives you everything that is inside your machine. If I set and then I grep, which is a command for looking for, I'll do this. I'll do echo PS1. There you go. My prompt is given by the variable PS1. This is this prompt right here. It looks confusing, but let me make it a bit simpler for you by changing the prompt. Okay, what I'm going to do is I'm going to say export, which is how you set variables. I want my prompt to be something really, really simple, a $sign. Okay, that is now my prompt. If I echo PS1, you see that I get back a $sign. That's the thing that appears on the left-hand side. If you want to have maybe a space in there, what you can do is make that your prompt, right? So now that every time I start off, I can say, okay, what's my prompt? It's something and then a space. Okay. If I want it to be more complicated, I could say, you know what? I'd really like to put my username /u and then my host inside my prompt. J Monroe, CMSC6950. Oh, you know what? I'd like the @ symbol to be right in there. And you can see that now my prompt is J Monroe at CMNC6950. Okay, so this is my prompt. Okay, again, echo $PS1. Now that is almost the same as this prompt. There's a few other things. I think the prompt that we're using has a colon, and then it has what's called your working directory. And then it has a colon, working directory, $ space. There we go. So now this is my prompt. It's got a name, an @ symbol, a user, a the working directory. If I go into a subdirectory, right, it changes my directory. I can add in additional things into my prompt, however I care. Oh, and my guess is my internet just died for a moment. Oh, that's sort of weird. Oh, come on. Come on, internets. Okay, let's try this again. Let's say that what you really wanted was you wanted the date to always know the date. Let's make the time. Or not D. The date, yeah. You wanted to always know what the date was. So what you could do is you could modify your prompt so that the date always appeared beforehand. Okay. You can put whatever you want inside this string to make the prompt whatever you like. Now, there's one other thing, though, which is if you take a look at the default prompt, you'll see that the default prompt is not just that, it's /03301:32M this. What is that? Well, these are called escape codes. If you were like a billboard, like a bulletin board system user, a BBS system user back in the day, you might be familiar with like ANSI codes. They're just a way of telling the system, I want you to make these characters a certain color. So what this is doing is setting the color of this word, and then it's changing the color to make it this symbol, and then changing the color to be this thing, and then the color for this thing. I do not know off the top of my head what the different colors are for these escape codes. So if I was interested in changing my prompt, what I would do is I would use a tool like, and I'll do a new share. I will share, here, we'll share a web browser. I would use a tool like, and there's a number of these. Here. I put it in Slack for your things. This is a tool which helps you develop whatever type of sequence you want. So suppose you wanted the time with the seconds, and then you wanted a hyphen, and then you wanted your name, and then you wanted an @ symbol, and then you wanted the host name, and then you wanted a $, okay? And you wanted that to be your prompt. This is what you would type in. If you wanted the time to be yellow, and you wanted your username to be magenta, and you wanted your host name to be blue on a red background, and you wanted the $, to be, no, not that one. I want this one to be red on that one. This kind of prompt, this would be your thing you want to type in. And the /E, 33M, 35M, 3446, this is setting the foreground and background color. But the way you use it is you take this string as it is, and then copy and paste it into a bash RC file and set that variable. And they've just encoded it in a different way, but that's how those prompts are set. Sometimes people care about prompts. You can do some searching if you end up using the shell a lot. Some people like really customized prompts. I will just show you a server that I use often for development, and I'll show you what my prompt tends to be. Log in just to give you a sense here. So when I'm doing, let's go to, PyGeo API. Okay, so here's a project I was working on. No, I want, yeah, okay. So here's the prompt that I use sort of day to day when I'm doing my work. I played around with it. I've made it fancy. What it's showing is the directory. I don't really care what my name is of where I happen to be, and what GitHub branch I happen to be on, and with my prompt. And so for me, this is my prompt. Okay, and you may go, whoa, that's confusing looking. But that's just what my prompt is to give you this fancy sort of effect. There are a whole bunch of sites out there. Go ahead and play with your prompt if that's something that's exciting to you, or just don't worry about it and take the defaults all the way through. Incidentally, bash RC, any commands you put in here will be run every time you run the computer, including something called aliases. So the other thing that bash can do is it supports the idea of having commands that you type in often. So let's say that you had the need to always go to a certain directory. Say in your workflow, you were just finding that you needed to go to data, PDB. Yeah, you needed to go to this directory all of the time, okay? One of the things you could do is you could set yourself up an alias, and you could say, you know what, I'm going to say that CDP, change the directory to this, is equivalent to this line of code. Okay, and now it doesn't matter where I am. If I say CDP, it will do the equivalent of whatever this line is. So alias, there's always a whole bunch of aliases which are set up. Here are a number of aliases which are set up by default. ls has some aliases. Say you wanted to do, remember, are we talking about als-lf? Well, maybe this was too long for you. So just ll is aliased to this thing. These aliases are typically configured not necessarily within bash rc, but inside of a file. Yeah, just send them a bash rc file, and you'll see a bunch of commands. If you put that in your bash rc file, you can set up a bunch of aliases however you like. Anyways, just things that I find useful that you should know about. We'll exit out of there. We'll clear out of there. And we will find my notes that I was following because I've lost where I am. Okay, so we've talked about SSH, we've talked about scopy, we've talked about remote servers, we've talked about bash customization. I think we're up the point of having a conversation now about something called Git. Okay, so before we get into this conversation, I think it's a good time to take a sort of a short break, because we're going to sort of launch into a new topic that I want to keep together. So what time is it now? So where I happen to be, it's 12:44. I know that in St. John's, it's an hour and a half later. So what is it? 2:15? Yeah, it's about 2:15 right now. So I'll say that as a thing. But here's the request in this 10 minutes, besides walking around. If you don't already have a GitHub account, okay? Right, it is 2:15 right now, so in 10 minutes is 2:25, right? Yes, I think that's correct. If you don't already have a GitHub account, please go through the steps of creating that so we can continue with the next part. Otherwise, I will see you in like 10 minutes. Get up from the chair, stretch, do whatever you need to do, and we will get back to it. Okay, cheers. Talk to you in a minute. Okay, I guess we'll get back to it. So the next task to talk about is I'm going to show you a comic. Let's see, new share. Yeah, hopefully that's going to come up relatively cleanly on your machine. Does that speak to anybody? Anybody's got that experience? Right? It is common that when you're sending a file around, you got different versions of it. Now, this is always worse when you're working in a group and someone's got a letter in a Word document and you send it by email to the group, right? And so there's always like James's version and Bill's version and Allison's version and Linda's version, and you have to reconcile those things together, and you end up with these ridiculous file names, and it's just a mess. This problem of trying to collaborate on multiple people collaborating on one file is something that has been solved for a while now, but we don't actually seem to solve it very well in science in general. Now, the reality is we've come a long way in the sense that whether or not you're familiar with tools like Word track changes or Google Docs or other ways of doing version history and collaboration, there's tooling out there that lets you collaborate on a document from multiple locations and keep version history. But it's taken a long time to get there, and it doesn't always work. And if you're limited to things like Microsoft Word, how do you do version collaboration on code? Well, it turns out that the problem of collaborating between multiple versions of a document is now a solved problem using something called a version control system. And so what we want to do is I want to introduce the idea of a version control system. And effectively what it is, or the kind of version control system we're going to talk about, is one that looks at incremental changes to a file and tracks those changes to a file. So specifically, the concept or the idea that we're gonna base our version control system is on the following graphic. And so I'll just go back to this thing again, share, here we go. What I want you to do is I want you to think about any line of text that you ever write or type in or do something. I'm thinking code, documentation, and LaTeX file, an edit. What fundamentally it is, what makes a document a document, is you've got some base, and then you add something to it. So this orange thing represents a change. So now you have the change document. And then from that, there's another version. So you can think about history or version history as being the sequence of successive changes to a file. And that way of thinking about documents not just being a bunch of lines, but lines that are built up through these sequence of changes, lets you do a couple really cool things. One is you can undo them, right? So if I added 3 lines and I didn't like those 3 lines, I could just undo this change and go back. But it also allows you to solve the problem of what happens when 2 users both make a change to a file. So imagine I'm writing a document and I make some changes to my copy, you make some changes to your copy. We now have 2 different copies of the file. And so on the right-hand side, this is supposed to indicate there's no newest version. We both have a newer version. If what we've done is recorded what our changes are, software called revision control systems or version control systems can apply each one of these changes and basically merge these 2 outputs together. So effectively what can happen is it can say, okay, I get that this yellow line was added between the first and third line. I get that the 2 purple lines were added at the bottom. I am able to, on my own, the piece of software, merge together files. Internally, in track changes or version history, something like this is going on inside of the system. What I want to do is go through a particular version control system and learn how to use it and what's going on. Okay, so the version control system that we are going to look at is called Git. Okay, so my hope is you A, have a terminal, B, you have Git, and when you say Git, something pops up. If you don't have this working, remember you can always jump on and use this shared Linux. '6950. You always can use this system, and on that machine, there is a copy of Git. Go ahead and use that. It doesn't really matter which machine you want to use. You need to have Git. Okay, what Git's going to do is Git is an example of a version control system. There are several of them. RCS would have been one of the older ones. I remember CVS being around, then Subversion, and there's a number of commercial products. But Git has become sort of a de facto version control system that is used, at least in science research and development, more and more. So we're going to talk about this, and its two reasons are to support basically an unlimited amount of undoing. You can undo changes, and allows people to work collaboratively together. And for collaborative work, one of the examples of collaborative work that I want to bring up is collaboratively working with yourself. Okay, and what do I mean by that? Suppose you have some files on this computer, okay? Data.shell, okay? And this is your home computer, and you've gone in and you've done some writing on your thesis, okay? Okay, and so you have gone and you have modified your thesis on your work computer, and you've made some changes. Then you go to school, you go to work. Let's pretend we're in the world we're allowed to go to an office. And you sit down at your computer, which is in your office, and you're like, oh, I did this work on my home desktop, but I'm now on my work desktop, but I really need to work on my thesis. And so you come along and you open up a directory and you start looking at your writing, and you go into your thesis, and you add some stuff, some new stuff. Okay, so here is the situation. I've now got two different computers. On this computer, this is the contents. On this computer, this is the content, and they're both good. I did some work yesterday, I did some work today. I want to merge this stuff together. Here is an example of you're collaborating with yourself. You're collaborating with yourself at two different computers. Version control systems solve this problem, so you never need to worry about editing the wrong version of the file again. This is why we're going to care about this. Okay. So first thing is some setup. As I said, I need to assume, if you're going to follow along with me, that you've got Git working. And I don't really care what version it is, as long as it's Git version 2 or higher, will be just fine. The very first thing you need to do when using Git on a new machine is configure something. You need to configure your name. Oop, that's not great. Git config global. You need to configure your name, and you need to configure an email address. Okay, these are requirements of Git. There are ways of using a private email address and hiding it, but these are things that, not Minerlab, mun.ca, that Git assumes you have set up. So I'm just going to drop this in Slack for those who need to follow along. Nope, I need this one. Okay, so I want you on the system, I assume you're working along with me here, to have those two things in there. That is essential. If you forget to do this, Git will almost start talking to you right away about errors that are in there. Here is the second thing that I want you to configure. your default editor. Now, depending on your system, okay, you may have an editor flag already set up. Mine's not set up. I don't have a default editor. But Git will try and use a default editor if you don't provide one. And often that default editor will be VI. Now, I like VI. I use VI all the time. I'm very fluent in it. It's not a big deal. Most people, though, don't. And so what I want you to do, remember how I asked you in assignment 1 is to choose an editor that you like to use. I want you to set that editor up with the following command: config -dath global core.editor, and then give me whatever the command is required to edit that file. So if you are a VI user, that would be it. If you happen to be using VS Code, that would be it. If you happened to do, oh, sorry, no, I lie. It wouldn't be that. I lost it already. That is wrong. That is not the right command. That would be the right command. You want to put it into wait mode. If you use Node, not Node, nano-w, okay? Whatever the editor that you like to use from your command line, and this is why I asked you that in the first assignment, you should put the one right here. Now, I'll give you a link here. If you are looking for some examples of like, what do I want to type in? There is a table. I'll just go here and share. Okay, so here we go. Here is a list of editors with some of the configurations that might be set up. Whatever your text editor of choice is, you want to set that up. And it can be a Windows editor if you're using WSL. It can be an in-terminal editor. Notepad++, okay? Some of these editors need to have some specific options. Whatever your editor of choice is, you want that set up. Okay, once you've done that, you should be able to review the settings of Git, and I think that's enough, and we are good to go. So once you got all this set up, git config list should show you the settings you're going to use. And so I'm going to use VI for mine, but you use whatever you like. And these are these configurations. Okay, so Git is a command line program that has that is a certain way of interacting with files. There are graphical programs that will do what Git does. For the purposes of learning Git, I want to understand what it does on the command line. Okay, so here's what we're going to do. We're going to go through a scenario and pretend we are doing some research on a research project, and we want to use Git to manage our problem. So from your terminal, right? And the requirement here again is you are on a bash terminal, whatever you set up. What I want you to do is we're going to study the planets, okay? And we're going to do an investigation on the planets. So I want you to create a directory called planets. And yes, you can create this in an Explorer or a Finder. We're practicing using the command line. Create a directory called planets. Go into that directory with the command cd planets, okay? What we're going to do is we are going to tell Git that this directory is going to host or have what's called a Git repository. And the way that works is git init. So what git init does is it initializes this directory so that Git knows that files inside of it will be under version control, okay? If you do an ls, there's nothing in it. If you do an ls-a, you'll see that there is a hidden directory called .git. That is what git init has created. That's what's setting up all the stuff we need and care about within Git. All the Git commands are of this form: git config something, get init something, or just by itself get status. And what get status will do is tell you what get currently knows about this directory. It says a few things. We're on the master branch. I haven't committed anything, which is like I haven't made any changes, and there's nothing to commit, right? That's just the status. There's nothing there. Okay. So here's what we're going to do is we are going to set up this project about Git. Now, suppose we're doing this collaboratively and someone says, okay, you know what? I want to do planets, but I also want to study planets and their moons. So I'll probably need a subdirectory on moons. Okay, so there's the moon directory. Again, remember, there's actually a .git and a moons. A newcomer might be tempted to go into the moons directory, see there's no files in there, and say, well, I want to do version control on moons as well. So I want to do a git init here as well, so that you have a .git directory under moons. This is not necessary. When you create Git, you're not just doing a Git repository on a file folder, you're doing it on the whole directory tree. It's all the files that are at this directory level and lower down. It's not necessary to initialize every subdirectory independently. It's redundant, and it actually can be very confusing. If there is ever a time where you are dealing with a .git and you want to get rid of it, right? This is an example where we use .rfm.git. I need to recursively delete this directory, and I need to force it because these things are not the read write permissions are set. So be very careful if you're going to use this command. Make sure you're in the right directory to get rid of it, and that is undoing a git init. Okay, so right now there is no more .git in this directory, but if I type in git status, okay, it still will work. Why? Because in a parent directory, there is a .git. Question on Slack. Error, chmod on, users get an option file mode to false. Okay, so what you're encountering there, Michael, is well, first thing is you are editing files on the Windows side of the world from a Linux side. So you're creating files on a Windows partition. It's entirely possible that you need to set this core.file mode thing. What I do is I don't edit my files on the Windows side. And this is only going to apply. You can read any of the files you want on your C drive by looking at Mount C. So if I go to users and then J Monroe and then see, I don't have a documents. Do you really have a documents directory? I don't have a documents directory, but I'll make one just so I can follow along with you. Make directory CMC_6950. I'm just doing exactly what Michael did. CMC git init. No, that works for me. Here's what I would suggest. When we're dealing with this remote system, work in your home directory. So type in cd return. Now you're in your home directory. Create the directory there. Okay. Work in your home directory all the way through. If someone else who deals more with Windows stuff, it's a permissions thing, right? It's just how you're working with those files back and forth. But can't you just change the permission? Permission of what, right? I don't know what file he's changing his permission to. Right, it has to do, okay, permissions. Permissions, these things are a Unix idea, okay? They're not a Windows idea. So when we try and set the permission flags for a file system, which is in Windows, I don't know if that's going to work. That's my concern. You're in a different kind of file system, a different operating system. Yeah, okay, great, no problem. So I said, if you're following along, I want you to have created a directory called planets. Inside planets, you can create a directory called moons. And I want to make sure that when you type in get status, you get that message all the way through. Okay, that is initializing a project with Git. It's that much effort to add Git to a project. Find a directory, do a git init, you're using Git. That's it. You're done. Okay. Now let's add some data. Okay, so let's say that we're going to study the planets, and the purpose of studying the planets is to figure out where we may want to build the next base in our solar system. I don't know, some story like that. So what I'm going to do is I'm going to create a file inside this directory that has some content. Now, use whatever text editor you like to use, and this is where this was important. If you like to use Nano, go ahead and use Nano. I'm using VI because I like VI. I'm going to create a file called mars.txt, and inside mars.txt, I'm going to add in some text. Cold and dry, but everything is my favorite color. Okay, you can type in whatever you want. Cold and dry, but everything is my favorite color. Great, because maybe someone likes the color red. Okay, no problem there. I save my file, I quit out of it, I do an ls. I now see this file, mars.txt, okay? And again, you can always dump out a file by using cat. I could use head, I could use tail, I can manipulate it. This is the file. This is something I've added to my system. If I now say get status, it'll tell me something. It'll say, okay, I'm on the master branch. You've never committed anything. Here is an untracked file. Here is a file that I don't know about. I've never seen it before. Files need to be explicitly tracked by Git so that it knows to keep aware of them. And so what you do is you type in git add mars.txt. Okay. And what that does is tell Git to add this file as one of the files to track. Now, if you now say git status, it says on master branch, no commits yet, changes to be committed. Okay. The idea of Git is it tracks changes. We've got a base file, and it's checking the changes. It's not just the changes to one file, it's the changes over all the files in that one set of changes. That set of changes is called a commit. The change is the addition of a file called mars.txt. If you add in additional changes to it, then the number of things we're committing will grow. It's only when you want to save all those commits as a package do they actually get propagated to the repository, to actually get saved into version control. And the way that you save something is you say git commit space commit. Now, here is something it requires. Git forces you to have a note, a message, what's called a commit message, some information on what you actually did. So I've added these files. It's saying, give me some information about what you're doing. So you have to give it a message about what you did. Well, what did I do? I started the notes on Mars as a base. If I do that, what Git will do is say, okay, I changed a file with one insertion, adding one new line, and I've created this new file. So if I say git status, it says on branch master, there's nothing to commit. The working tree is clean. What that means is the files in this directory are matching the files that are on inside the repository. Okay, we've talked about git add, git status, git commit. Git log shows you everything that's happened to this repository, and you can see that as of Thursday at 1:19 in the time zone that I happen to live in. By me, I did this work. What did I do? I started notes on Mars as a base. And this number is the hash that uniquely corresponds to that change. Okay? Now, under the hood, your files are still here, mars.txt. What git commit has done is copied something into .git. And that's where your reversion control is. That's your history. All the history is inside that directory. You are welcome to go into it and take a look, but you don't play. You don't edit any of the files. Inside this directory is all of the stuff that makes Git work. We generally don't touch it, okay? But it's there. Okay, so now let's say that you wanted to make another change to it, okay? So I've done some work and I want to add some more information. Okay, so I'm doing research on the planets. I add additional information. I can say it has 2 moons, so the moons may be a problem for werewolves. Just in case we have any werewolves on our planetary base, I could add in some additional information. So I write that, I save it, I quit out of here. Okay, so now if I say git status, it says, okay, I am noticing a difference between what is currently in your directory and what's in your repository. I'm saying, hey, look, there's a difference. It's telling you that 2 things. You have a choice. You either can add that file, which adds it to the next set of committing, or you can just restore it, basically delete your changes and go back to what you were doing. Okay. Now, just before I do it, I may want to know what those changes actually are. So if git add adds something to the repository, git diff shows you the difference between what's in the repository and what's in the current directory, okay? And you can see this is how Git is seeing the change. It's saying, okay, look, there are 2 files. There's mars.txt and mars.txt. There's the old mars.txt and the new mars.txt. The old one, you've taken away this single line, cold and dry, but everything is my favorite color, and you've added these 2 lines. So the change is remove this line, replace it with these 2 lines. And if you might be looking at it going, no, why did you delete this and then add all of this? It's this dot. I actually changed the whole line. Git works on a line-by-line basis. So that line was edited. So the old line is removed and 2 new lines are edited. That is the change. This is actually what's going to be stored in the revision control system. Okay. And okay, so now I can say, yeah, I want to add that. I can type in git commit. Now, here is where that editor thing came in. If I type in git commit, no, wait, no, I missed something. Oh, I got add mars.txt, right? Git status. So you add a file. This is adding it to the list of things to be committed. And then you say git commit. By default, it will open up your editor, requiring you to put in a commit message, okay? This is just a hint. You need to type in what the message is. If you don't type in a message, okay, it'll abort due to an empty commit message. It is forcing you to have good priorities. It makes you put in an editor. Which editor gets run is from that core editor thing. And this is why setting up your editor is useful. You want an editor that starts quickly. You're welcome to use Notepad++. You're welcome to use Nano. You're welcome to use whatever you love to use. But having an editor makes this efficient. Okay, you absolutely need to have a commit message. You either can edit it here in a text editor, add concerns about Mars moons on werewolves. Okay, I write it and I quit it. And I've done it. Or if you prefer, you could add that message right here. Right? In either case, what that has done is made it so that now there are 2 revisions to the Git repository. There's my original commit, which was that change that added the initial notes. And then my secondary one, where I've made another change to it. And that's what Git is doing. It's tracking the changes to these files all the way through. As a visual, you may be appreciate an image like this. Here is what the difference between git add is and git commit. So add doesn't mean add a brand new file. Add means add a change to what's called the staging area. You can add several changes all at once because maybe changes all go together. And then you can commit all those changes to the repository. And so Git always has these two steps of adding something to the staging area and then committing. There are ways of automatically doing it. So if there is a git commit -a, we'll just take all of the changes that are there and add them all up for you. While you're learning this, I would suggest strongly that you intentionally add files to your staging area, verify that's what you want to commit, and then commit that to your repository. Okay, that's the basic idea of using Git as a version control system. Okay, we'll continue on here. And a lot of this might be like, well, why is this? Why do I have to type this stuff in? This is what's going on behind the scenes, and understanding what's going on behind the scenes lets you fix problems when it comes to it later. Okay, so let's continue to add some data to it. Okay, so let's go ahead and add to my file again, make a third change. Okay. Humidity. Okay, mummies, as in the things wrapped in cloth. By the way, the moon base is for monsters, Dracula, werewolves, and the werewolf and the mummy. Let's say I wanted to add that site. Okay, so I've now added that to my files. I've now got 3 lines in it. As you know, if you do git diff, it'll show you the difference between what is in my repository and the current file all the way through. Right? So let's add that file to the staging area. Okay, so again, git status. Okay, there is nothing staged for commit. How do I solve that? Git add Mars, git status. I've now got one file in my staging area. Before I commit it, I may just want to remember what's in there. Maybe I don't want to commit this. Maybe I want to back it out. If you just do git diff, you won't see any difference. And that's because what git diff is doing is it's looking for the differences between the files that are in the current directory and in the staging area. If you want to look at what the difference is between the staging area and the actual repository, that's git diff staged. Okay, so this is a different option. This is looking at what's different between the files in the staging area and the repository all the way through. Okay, and then we can continue and we can log this. So we practice doing another log, git commit -m, discuss concerns about Mars climate. Okay, and we've made the commit. So now if you do a git status, nothing is clean. It's all clean. Git log. We've made 3 changes to the final file. The initial commit, the second commit, the third commit. And this is the basics of the idea of version control. Okay. Every time we make a change, and it really doesn't matter how small the change is, we can add that in. People do dozens of changes in an hour. You don't need to wait till your project is done. You can just commit as often as you like all the way through. Sometimes, especially as the number of commits get long, you want to sort of see this in a more compressed way. So git log -1 will give you only the very last commit. You only care about the very last one. Alternatively, git log -1 line gives you every commit, but only as a single line. So it got rid of the time, and it just put excuse me, the commit hash and then your note so that you can see the history of what's happened to this repository. In fact, it can do a little bit of visualization and show you that here is the sequence of files as a graph. Now, this is a very boring graph because it's just a graph of one dot after another after another. You'll see that when we start talking about branching and multiple users, why we care about such a thing. Okay. Couple caveats about Git. Git tracks files. It does not track subdirectories. So if I was to go and create a directory called spaceships, okay, and you see mars.txt moon spaceships, and then I say git status, it says nothing to commit working directory clean, okay? If I try and go git add spaceships, git status, nothing to commit working directory clean. You can't add a directory, okay? You have to have something inside of the directory to be able to add it. So if for some reason you actually need to have an empty directory, there's various ways of doing it, but usually people just put a hidden file inside this directory. You have to have some files in there, even if those files are empty, okay? Say I create a file called Apollo 11 and a file called Sputnik 1. Okay, so now inside spaceships, there's two files. Now they're zero size files, but there's files. Now I can say, hey, now there's some untracked files. You can either add each file separately, or you actually can add the entire directory. And what you'll see is now both those files are being put into the staging area. And if you want to commit that to the repository, you say git commit and then the message, add some placeholders for spaceships. Okay, and you created these files. Okay, so to recap, what we're doing as we build up this repository, it's made up of files. The files are built in a sequence of changes, and it's those changes that are being recorded inside of the Git repository, and that's what git log is doing, right? Each one of these is a change all the way through. Okay, now here's this is a good question. So how do we push those files in the repository? You already have. They are in a repository. So this gets a little bit weird because Git is an example of a distributed repository. So this repository is the complete history of it. The repository is inside this directory. Oh, right here. This is the repository. The active git.push, that has pushed it to the repository. That is a fully defined, the complete repository. You are done. What you're getting at is how do I push it to something like GitHub, which is a different thing altogether. And I'll talk about GitHub, but that's not Git. So we're dealing with Git. Git is you have a repository, a .git, and you're making changes to it. And I will get to GitHub, but we're not quite there yet. Okay. So the next thing to discuss when we're talking about Git is how to find changes between these different files. Let me just go back through my notes, make sure there's nothing I've missed. Yeah, we're fine. We can just continue on. Okay. What I want to do is I want to talk about this history and how I go about modifying what's going on. Okay, so let's do one more change to our Mars file. I'll just add in a sentence, an ild considered change. Doesn't matter what you write. You could write your own stuff. Okay. If I do a git status, okay, again, there is one file that is different. Okay. I can use git diff to see what all the changes are. But what I can also do is look at the difference between very specific files. I could look at the difference between whatever is in the head and the file itself. Nope, not GIF. Git diff. I don't know where my character is there. So when we talk about git diff by itself, what that's doing is looking at the difference between a file and what's called the head of the repository. Again, git log, one line. Do you see this word head? This is the top of a whole sequence of changes, and it's the one we assume we are always making differences to. But I don't have to compare a file with the most recent copy. What I can do is I could also take the difference between the previous version and the current version. So what this is saying is, no, previous version, right? This is the difference between 2 versions ago and the current version of the file. So if I wanted to understand how files were changing, I could sort of group them together, and I can say what changes were made in this file between 2 versions ago and the current version. This is important because when you're trying to figure out where bugs in code get introduced, you want to know who made the change, when did the change work. I don't know if you ever worked on code before where it worked and then you came back to it a few days later and it now doesn't work. Using these tools will let you figure out what has changed with going out. If you just actually want to see what the file looked like in a previous version, you can use git show head. Let's go 3 versions back and look at mars.txt. Okay, so this is the old version of the file, the old commit associated with mars.txt. Here is the commit associated with a recent version of it. And again, what we're seeing is we're seeing the individual commits, and a commit is a change to a set of files. So I can go and I can dig up and look at all these informations all the way through. Okay, so you can look at these things and go back and forth and back and forth. This idea of head is really useful because the alternative is addressing things with these commits. If I wanted to, instead of talking about head and head -1, -2, -3, I could actually use these commits as well. So if I wanted to, I could look at the difference between this commit and the current version of the file, and you'd see the changes between those two. Head is a sort of a shortcut to what that key is. This is how Git is using to track the individual lines of each file. Okay. Okay. Let's keep on going. Let's imagine that I've done some editing here. Okay, and what I want to do is I've made a change, but I don't like it. Okay, so I've modified the file, I've added an ill-considered change, and I want to get it back. I want to go back to what the file looked like before I made that change. I want to undo this, right? I said that was one of the features of it. I know the git status says you've modified this file. How do I get that file back? Well, what I can do is I can check out from the head, from the repository, that file. Okay, so again, if Git is tracking a series of changes and the most recent change in the repository is called head, what checkout does is it copies the file mars.txt from the head and updates it. Okay, so one path from this is the hash from that repository. If I was to take a look at mars.txt, you'll see there's changes gone. There's only 3 lines, not 4. I have removed that change all the way through. In fact, I can check out a file from any version of its history. So if I go to git log one line, okay, each one of these is a version of the file in revision control. So if I say git checkout and I pick maybe the very first version of this file, okay, I have now updated that file, and now mars.txt looked like it did before I started doing any editing of it. Okay, and I've made that change. If I go to git status, it is telling me, hey, this file's different, right? You've basically gone back in time, pulled an old version of the file out. If you want to make that the current version of it, then you could add that and keep it. Or you could check out from the head the current version of it, and then you'd have all the stuff back. So this idea of checking out a file allows you to take a look at what the files look like at a particular point in time. So how do the things work together? Git log, not one line, tells you all the changes you have ever made. Git checkout allows you to pull from a version, either head or one of these repos, any particular file, right? In fact, you can check out an entire directory. Okay, and this is going to give you a bit of a warning. You're in an attached head state. You are now looking where this is the entire history. The file, you've rolled back time to look at where it was. To get rid of that, you want to check back out the master branch again. Okay, so there's always this idea of a bunch of history, and you're git log one line. You are moving up and down this history by checking out files up and down it. And what that's doing is it's either rolling the changes forward or rolling the changes back and forth. Okay, so how do I go about recovering a file? I pull it from a previous version of the directory. Okay, let me bring this back here, and we'll do this as an exercise so that you can sort of do this. Okay, I'll just put something in Slack for a moment. Okay, so here is an example. I've just thrown it in Slack. Suppose your Jennifer's made some changes to a Python script, and she's been working on it for weeks, and she did something that broke it. Now, fortunately, she's been using version control, and she wants to go back to a previous version of that Python script, right? So you have some text, you have some code, it used to work and it broke. Which one of these options, 1, 2, 3, 4, or 5, do you think is true? And again, use the thread to sort of give me what your answer is to those things. And if you want to play with it, you could always go to your environment, create a file in it, right? I don't know if you know any Python, but there's something really simple. Right? I want to go back and I want to recover this previous version that I had saved before. How can I go back and do it? How do I go back and get from the head this file that only had that one line, not a change to it? So the question is 1, 2, 3, 4, 5, which one would you do? And again, I'm looking at Slack here, and I am looking for an answer, and I'm seeing nothing, which worries me. Oh, we have some answers. Okay, so we have one answer. Number 5, both 2 and 4. Anybody? Number 1. Okay. Okay. Any other answers? Oh. Number 4. Okay. Again, Omid, try and reply in the Slack channel thread just so we can keep the answers together. Oh. Someone just gave me a message in Zoom chat. Please, everything should be in Slack. Use Slack. No one's going to be looking at the message in Zoom. So say whatever you want to say in Slack. And again, use the thread. Oh, 5. Okay. So Jinyao, put that in the thread, not in by itself. But okay, we have a bunch of different answers. Clearly, we want to talk about this. So we have one person said 1, one person said 2 and 4, one person said 4. Okay, so which one is it? Let me just go through this here. 5. Okay, I agree. The correct answer is number 5. Okay, the cracks. Yay, exactly. Number 5, it's both the 2. Let's just talk about what's going on here. Okay, what's going to do, and here's the scenario. Right, I've got a file. Okay, and I've made a change to it. I know I've made a change because I can see my changes, and I want to pull out the previous version of it. Okay, if I say git checkout head, that's going to go back to my repository and pull out that file. I could also look at my git log and grab the commit that is the same word as head. So head and this phrase are the same thing. So either one of those two things, number 2 or number 4, work. If I use number 3, that would pull out the version before that, which isn't what I want. And I want to talk a little bit about why git checkout head is not what we want. This can be dangerous. Okay, what this does is it would revert the entire repository back to what it looked like in head. Okay, it would override all of the changes you were looking at, right? You may only want to change data cruncher, but this would bring us back to a previous version all the way through. So be careful about what you do at git checkout without a file. It can put you in a detached head state. Yeah, it has value. Just don't do it on itself. Git checkout head data cruncher. Oh, Arnab, you put a message in there. Why do you think you got that particular error? Why do you think Git is saying in the head there's no file called datacruncher.py? Well, that's part of it. I would say that in your repository there is no file called datacruncher.py, so there's nothing to pull. You have to have the file in your repository to recover it, right? Again, if you get it wasn't committed exactly, so you were so you're trying to pull a file that didn't exist yet. Okay, so just to get us back in a good state, if you say git status, right? We want to put things back. So I'm going to get checkout from head. I'm going to recover that file, do git status. When I do git log, online, not online, one line, I want it to look like that nice and clean. Okay. you can revert commits, because this idea of undoing something is so common. There is a command called git revert, and what git revert will do is undo a particular one. I can remove some line that shouldn't be in there, right? I could take that whole commit, and what that will do is revert it. Now, it's going to give me a default message, but I'm welcome to do that if that's what you want to do. Git log one line. So you can see what happened is I added a file and then I reverted it. Reverting doesn't undo it. What it does is it does the exact opposite of it. So it keeps the history of both the adding and the removing of it. This is something about Git. It's very difficult to delete something. So if at any time you were to do the following, okay, let's say that you had some data, okay, data.txt, and you put in the secret password into your file, and then you said git add data.txt, and then you said commit my data file, okay, and we look at the history, right? There's my history, and then you go, oh no, I've saved my secret password to my history. If you were to go and say, no, revert, I want to revert this change. I want to go back. I don't want to do this anymore. Right? Then data.txt will disappear. That's fine. But remember that it's still in your history. Okay? It's still sitting there in the history. If you by accident put sensitive information into a Git repository, like a password, there are tools that let you go and edit the Git repository and remove that. But the reality is, if you've done that, just change your password. Assume it is public if you have ever committed something into version history. It is tricky to truly undo a commit. And you want that to be true because you want to keep the full history of what's going on. Okay. Okay, so we talked about how do I undo a file, how do I undo a change? Git check out. You checking out a file from an old version of that repository. Okay. There's a few other things you should know about using Git. Okay. Often there are files that you don't need to put under version control. So a lot of you guys are in computer science, right? I don't know if you're familiar with it, but let's say you wrote a program, myprog.c. Okay, let's just see if I can do some old school C programming. Let's see if I can remember how to do this. Standard io.h, main, maybe it's an int. Let's see, printf, hello world, n, $, return 0. Okay. I'm using a quote. Okay, I think that is valid C code. Okay, and it doesn't really matter what it is. There's myprog.c. I'm going to compile it, and I'm going to first compile it. Oh, I don't have GCC. That's fine. Don't worry about what I'm doing. I'm just trying to demonstrate an example where this would come in. This is why I like using Linux. Really easy to install software, right? Apt install, done. You got some software to work with. Installing. Doesn't really matter. I want it to work. I want it to work. Oh, come on. 99%? Okay. So I compile a function, right? Start programming stuff. I have this file called .io, and then I link it together. Myprog is thing, myprog.o. Okay, so now I have a new program, myprog. It spits out hello world. It's a great little program. Let's say that what I wanted to do was save my changes. So if I do a git status, you can see that it has 3 files. Okay, now getprog.c, that's my source code, right? So you could dutifully say git add my prog dot c to it, and you could commit that. Okay, my first program. Maybe not my first program, but it's often people's first programs, the hello world. Get status. Okay, and then you go, oh, but I don't really want to put this object file in source control. It's not something I'm going to ever edit. It's just the output. I don't want to put that in source control, but I want it to sort of disappear. What you can do is you can create a file called gitignore, .gitignore, and any files you put in here, either explicitly or with wildcards. Okay, if you have a .gitignore file, when you get status, it will ignore files of that pattern. So often in a Git repository, you're going to have this hidden file called .gitignore. And again, inside of .gitignore, what you do is you list files that you want Git to just ignore, not consider, so that when you do get status, they don't pop up. Now, saying that, gitignore itself is a file, so we typically add .gitignore to the repository. Use a gitignore file. Okay, and so now we can say git status. And so now my error message is very, very clean, even though there are files which are never going to be checked in. So gitignore is a nice sort of tool all the way through. You should know about that. How we doing? Okay, let's get to that question about pushing to remote repositories. Okay, so now we're going to talk about not just making changes on one computer, but how do we go about making changes between multiple computers? Git is a distributed version control system. And what that means is all the history is actually stored inside this Git directory. The full history of every change is inside .git. If I want to collaborate with someone, I've got to give them access to this repository. You actually can do this. Two people work on the same computer just by knowing where their paths are. Git was developed by a guy named Linus Torvalds, who developed the Linux kernel. And when they pass Git back and forth, they do it all over email. There's no need for a centralized repository. But it was found that it was really convenient to have a third party hold on to a copy of this repository so other people could find it. And that's what GitHub is. GitHub, Bitbucket, GitLab, they are all services which offer hosting of files that are Git repositories that can be cloned, pulled, and pushed to. The ideas of pushing and pulling are Git ideas, and a repository is a remote repository you're sending or receiving files from. GitHub is one of the places where a Git repository can be hosted. Okay, let me give you an example here. I'm going to go to a new share. I'm going to share my screen. I am going to pull that out, and I'm going to show you Git. Okay, so this is github.com. Okay, oh, here. Sign out. Yay, github.com. It doesn't have to be github.com. There's just a few people who tend to use it. It's pretty popular. Now, Bitbucket has a bit of use and GitLab has some use, but 65 million developers. If you're a computer science person, you probably have an account on GitHub. And if you don't, you should, because this is sort of just where the world goes to find out what kind of developer you are. Assuming you've signed up, right? We sign in. I obviously have multiple accounts because I do that kind of stuff. So I'm going to sign into my account. Boom, I am now on GitHub. And so this is what it looks like. Okay. What you're seeing is these are all packages that I've either collaborated on, committed to, set an issue on, I'm following, I'm doing lots of stuff. And then I've got a lot of repositories myself that I might be looking at. you can go to a person and you can look up their page, right? Here's my profile, right? So this is sort of like what I do. This is a snapshot of who I am. I've been using GitHub for a couple years now. 2013 is when I created a GitHub account. And it shows you like every commit you do. I don't use GitHub every day. I'm teaching, I'm developing, I'm doing lots of different things. Some people have like commits every single day. I'm spattered, depends what I'm working on. And you're able to create a bunch of repositories. And I create repositories quite liberally. So I've got 81 different repositories that I've created. Some of them are historical, I'll never go back to. Some of them are private. So, for example, the grades for when I taught this course last term are in a private repository. I don't make that public. There are other projects that I do make public because I'm working with someone on them, or courses I want to share with students, or whatever. There's a whole bunch of different repositories. Let's say you want to take your planets project and share it with the world. What you do is you go onto GitHub, you have an account, and you go and you make a new repository. So whether or not it's from your profile or a button, you're looking for this word new, and you click new. And here is the create a new repository page. Now, you can have templates, okay? You might create repositories that have a certain structure and they're always the same, but usually it's no template. You give it a name. Now, you can give it any name you like as long as it's characters and letters. Since the repository is called Planets, let's give it the name Planets. Okay, and the description is research project for new planetary. I just disappeared, didn't I? Okay, are we back? I will. Oh, okay. Sorry, technology. I said it was. I'm surprised we made it through 2.5 hours so far. This is great. I was expecting to have even more problems. Let me recover. Let me recover. Share screen. Okay, let me just make sure we're on the same page because I don't know how long it was frozen. Sorry. Okay, so we are on a GitHub page, right? You have to be able to log into GitHub as yourself, create a new repository. The repository can have a name of planets, whatever you like. It's unique to yourself. A description of the project, project on new planetary base. And now you have a choice, okay? You can choose your project to be public or it can be private, okay? I'll make this project public, but if you're doing something which is not a public project, you can make it private. For this course, I'm going to ask you sometimes to create public repositories and sometimes to create private repositories. In particular, your assignments, put those in a private repository so that, it's just your work and you're not going to have someone copying from you. But for this project, let's make it public so everybody can see it. You can initialize this repository with some things like a README or a git ignore or a license, but let's just skip that for now and hit create repository. Okay, we're done. We now have a repository on GitHub, and it's telling you how to connect to it. And you'll see the lines here: git init, git add, git commit. That's the stuff we already did. We've already committed to a new repository, okay? What you need to do is you need to connect it with this repository. So what we're going to do is we're going to follow these instructions to connect our repository with this repository. So if you're following along, what I'm going to get you to do is take these lines and apply them to your repository. Okay, so I'll share the entire screen so we can see everything that's going on here. Okay, so there are the two big windows we got to care about, right? I'll get rid of that. We've got, yeah, I just don't want to get too busy. Okay, so I've got my planets project, and I've got these instructions. And what it's saying is to do what's called a remote add. Now, so get remote, okay, is all of the remote repositories this thing knows about. And what we're going to do is we're going to do a get remote add origin. And I'm going to get you to put in whatever it says here. Now, there's one of two things. It could either be an SSH, or it could be an HTTPS. Okay, it doesn't really matter which one you use. With HTTPS, you have to put in your password for GitHub. With SSH, it will use SSH keys if you've set that up. I tend to use SSH keys for everything, including for GitHub. And if you go through here into your settings, you can add a public key so that you don't have to type in your password all the time. But that's out of scope for right now. So let's just use the HTTPS one. Here's the line. Okay, I am remotely adding an origin to pointing to this directory. Okay, if I say get remote-v, it's saying what all the remotes are, all the remote origins. And one of them is GitHub, JMonroe, Planets, whatever. What I can do is I can create a branch and push this data to that remote branch. So I'm going to start by saying get, well, they've changed this. Okay, I'll take a step back. Usually what you would have done up to not that long ago is gone get, push, you, origin, master, and you'd be done. Why master? Because if you look at all of the history, you'll see that the name is master. Master is a historical name that was given to Git in the sense that this is the master branch, the original branch all the way through. GitHub, which is not Git, as a company has decided, you know what? The word master, some people have problems with. It master thinks about master slave, and especially in the American context, those words have a lot of context behind them. You know what? We shouldn't use that word because it really doesn't matter. We're going to instead call our main thing branch. We're going to call it main. It doesn't matter what you call it, but let's do that. So if I do that get branch, you'll see that what I've done is I basically relabeled it. So I've created a branch called the main branch, and now I'm going to take that branch and I'm going to push this main branch to origin. -u sets it so it becomes the default branch that I want to push to. Now, there's security. Because I use HTTPS, it wants to know what my GitHub password is, whatever you set it up as. And what it's doing is it's sending to GitHub all of the changes. Okay, you see it says compressing objects. Those objects, those are all the changes to it. Now, passwords are an old way of doing this. In fact, I just pushed it and GitHub sent me a message saying, you know, the password feature is deprecated. You really shouldn't be using it anymore. I would attempt, if you can, to do this all with SSH. You just need to set up an SSH key. Again, through here, go down to settings. You'll probably be able to figure it out. Play with it. It doesn't matter to me how you do it, but you probably want to use SSH keys. Now, jumping back to your web browser, if I restart this, you can now see your files are on GitHub, and they're publicly on GitHub. So if I go and I jump over to Slack, and I put that link, you can, no, I do not want to install the GitHub link. Thanks very much. You all now could go to a web browser and get a copy of my files. Okay. In fact, what you could do is you could go ahead and you can go to this code button, and you see it says again HTTPS or SSH. Let's do an SSH. This string is how I can make another copy of that file. So how would I make a copy? Well, let's go to a different machine, CMSC6950, right? And I'll just use HTTPS. If I say git clone this path, what that's going to do is make a copy from GitHub onto this machine. Now, this machine is this remote machine I've been using, not my local machine. Here is planets, and there is my data. So there is mars.txt on my local machine. Here is, oh, wrong button. No, I want to, is it Alt? It's Alt. Here is planets.txt on my desktop. So a remote machine, a desktop, and here is on GitHub. Each one of these three windows has a complete copy of the full repository. I could delete any one of two of these, and the other third would have all the copies to them. But once I have them linked up like this, they all have the concept of a remote. And so what I can do is I can make a commit on one of them. Say I come here and I add in a new planet, VI Earth. This was the original base. Okay, git add earth.txt, git commit, add info on Earth. Okay. Oh, look, I have never set this up. I'm on a brand new computer. I have never done git config. You remember I said I had to do that? Let's do that right now. Git config, jmonroe@mun.ca. It forces you to do this on every computer. James Monroe. Okay, now we do a commit. So now if I look at the log, one line, you can see how this one now has a slightly more interesting history. So I'll show you them side by side so you can see what's going on. This is on my desktop. And you see that its history, head is pointing to main, also origin main. So it's pointing to main repo on my main machine and also the main repo on GitHub. This one, head is pointing to main, which has a different change than is on either the head or the main. So if I want to propagate that change to other machines, what I need to do is need to say git push. Okay, and again, because I'm using passwords and I haven't set this up, SSH would allow you to bypass the passwords. If I push that change, it will send it so that now the head is at the same point as on my local branch and on the remote branch. In fact, if I refresh on GitHub, Earth and Mars are there. However, my desktop still doesn't know about anything to do with Earth. And that's because unless you actually pull information from here back, it won't understand it. So typically what you do is you do what's called a git pull, and that's the equivalent of a git fetch. And what it's doing is it looks at GitHub, finds any changes in GitHub, and adds them to this local repository. Git, we'll do long one again. And you see now that the head includes add info on Earth. Okay, playing around with one version of the files, another version of the files, and GitHub is a good way of understanding how these different ideas work together, right? In terms of pushing and pulling. So we finally got to your question, Omid, which was, how do I push those files in a repository? What you do is you create a repository on GitHub, you add the remote, and then you do a git push. And git push and git pull is how you put those files back up and back down. Okay, the one thing we haven't talked about yet is branching. But I think what I'm going to do is stop sharing for a second. Share screen. I want to find, here we go. Okay, so these are just the notes that I've been following, and you can sort of use these as the textbook. The same information is in the actual textbook. It explains how to push or pull to a remote repository, so you can read through that and review these ideas and what's going on. It's got information about the difference between HTTPS and SSH. You should probably review that. Everything we've talked about. The next section here is on collaborating, okay, which is the idea of pushing back and forth between different people. I want you to work through this. So work through this exercise, collaborate with yourself, make some changes by having a GitHub repository and just seeing what happens when you add files back and forth to see what the workflow would do, and then read about resolving conflicts, okay? So this is something just to work through and be like, okay, I see what's going on, but this is much better experience by working through it. Look about conflicts, and then there should be one last section on branches. Okay, don't worry about open science. I want to go to the table of contents. So what we have done is history, ignoring thing, remotes. I want you to, on your own, sort of work through collaborating conflicts. I will continue with this stuff later on another day, but that should be enough information for you to go, okay, I think I understand the idea of what's going on. Here's how I'd like to evaluate whether or not you understand the idea of what's going on, is with an assignment. As I said, I'll try to have an assignment every day. So here we go. Again, I'm just posting the assignments for those who are enrolled in the course onto Brightspace, which is the product from Desire to Learn, course content. Okay, assignment number 1, some of you have done already. That's just a quick email to tell me this is all working. Assignment number 2, what I'm looking for is a single file that shows that you've used the Unix shell, okay? I fixed this mistake because we talked about that at the beginning. We had the wrong link. And in fact, someone else pointed out that the file ended right here. There is a question 11 and question 12 and instructions, and I just forgot to copy and paste them. So please do the entire assignment. But the thing on the end is what's important here. Turn in this piece of homework by sharing it with me on a private GitHub repository, okay? So what do I mean? I want you for this assignment to create a repository, private, called this CMC6950 _ assignments. And when you're doing this, pay attention to exactly what I've called it, okay? CMC6950 assignments is different than if I had a lowercase a or a dash, or I put a hyphen here. Use it like that, and that's only because I want to pull 21 different repositories. And if you all use the same names, then I can just run a script and do it at once. Otherwise, I've got to like individually handle each one. Once you have done that, use GitHub and share it with my GitHub account. That lets me see it, and only me seeing it. Once you've done that, clone that repository to your computer and add your answers into that file and push it up. That's how I'd like you to submit your assignment to me for that assignment number 2. So a private GitHub repository with a bunch of shell stuff. Assignment number 3 is actually on Git. And so the purpose of this assignment is to practice working with a Git version control system. And so it's got a bunch of tasks, okay? You've already done number 1. You set this up. I want you to create a new local, that is on your computer, Git repository with this name and do the following steps, okay? Create a file with a text editor. Now, your full name isn't your full name. It's whatever your name is. Do a commit with this commit message. Do another paragraph with this commit message. Go through those steps precisely, and then try something which is called branching. And you're going to have to look up on the notes on what branching is. It's basically git checkout new branch. And what I want you to do is go through the sequence of instructions so that when you look at the log, this is what the log is going to look like, okay? Git log, you're going to have this idea of a branch and explore that, and then push that up to this public repository called CMSC6950 get assignment that's used only for this repository. And I got a little bit of a marking scheme here, okay? And the idea is to practice using gits as it's designed from the command line. I've already done this, and if you look at my repository, CMC6950 get assignment, okay, this is what your solution should look like. Oh, that's not going to work. Whoa, that's weird. Assignment 3. Open a new tab. Gem Monroe at thing. Obviously, there's an error in that link. So here is that repository, and it's the history that I'm caring about, okay? Like, so if you go and you take a look at the history of these files, that's what I'm really caring about, okay? These commits, right? What you actually did in each and every one of these commits. And what I'm going to do is I'm going to clone your repository and see whether or not you did it correctly. Right. User ID should be your Git repository. Anyways, try and work through that. So you now have a little bit of work to work on over the weekend. Here's how evaluations are gonna work. I'm setting these assignments to be due a week after I post them. So assignment number 2, it's due on Monday. Okay. So by Monday, I expect you to have this done. On Monday, I am going to call on a couple of you to show the class your solution, okay? So by Monday, have this done. The expectation is for everyone to do it. Obviously, if you can't make it, don't worry about it. I will eventually find you and have you do an assignment, but try and have it done for Monday. And I'm going to ask you just to talk about what your answers were to these different questions. Then on Thursday, which is a week from today, assignment 3 is going to be due. Okay, assignment 3 is due a week from today. And again, I will pick on 1 or 2 people to just explain to me how you did it, what challenges you encountered, do some participation, just demonstrating that you did the work. And so assignments are going to be taken up a week after they're presented. So what you're working on right now is assignment 2 for Monday and assignment 3. That's my spiel. Anyways, that is, again, a ton of stuff. I will be taking, stop share. I will be taking the recording of this. The recording has to download. It's got to be converted to a different file format. I got to upload it to YouTube. It'll appear sometime this evening, very early tomorrow morning, depending on whenever the computer finishes doing its thing. You don't need to rewatch this whole video. It's mostly there for those who couldn't connect to it. But that's where we're at. So just in the remaining 5 minutes or so, any questions or comments? I don't see anything in Slack.
Hello, Professor.
Yes.
I was trying to start my text editor, Notepad++.
Yes.
Not one from the shell, the basic software, Notepad++ from using the shell.
Yep.
So I accidentally set up alias in the bash source file.
Mm-hmm.
Like the path, I just set the path is equal to np.
Yep.
And now whenever I press np, the notepad starts. So you have a line in the assignment. It says that at the end of the assignment 1, I can edit a file with VS Code directly from the shell using the command code something
Yep.
code.
Mm-hmm.
So if I just give you like the np and /np space the file name, so
Yeah.
will it be counted? Or
Yes.
do I need to
I would
give
probably add in the sentence saying, I created the alias, tell me the alias, so this command works for me.
Yeah, thank you.
That's great.
Thank you so much.
It just, you often need to go back and forth between using your full screen, and you want to use applications like VS Code or Notepad++, which are Windows applications, to edit
Yeah.
files. And then sometimes you want to edit files within a terminal. And I just want to make sure you're able to do that.
Yeah.
You'll need both eventually in your life.
And opening Notepad using the whole path is
Well,
little bit time consuming.
Which is why we talked about aliases.
Yeah.
Exactly.
Thank you so much.
Exactly. Yeah. Perfect. Okay, thanks everyone. I will see you next week. Have a good weekend. Cheers.